Hello, this is Amir. This presentation introduces Face2Scene, a novel framework that redefines diffusion-based image restoration by leveraging facial degradation as an oracle to guide full scene reconstruction. This work is done during my internship at Samsung. In this presentation, I'll walk you through the full pipeline behind our Face2Scene framework. First, I'm going to talk about behind face-only restoration. I will start by explaining why conventional methods that focus only on face restoration are not enough, especially when the entire scene is degraded. This motivates the need for a holistic approach. Second, I'm gonna talk about the face-to-scene overview. I will briefly walk through our two-stage pipeline. Next, I will introduce our synthetic and real datasets, and then I'm gonna talk about the results. We'll look at metrics showing how face-to-scene compares to existing methods. And then I will show visual examples showing improvements in global scene quality. And finally, I will wrap up with the main insights. Recent advancements in image restoration, particularly with diffusion models, have significantly improved perceptual quality and realism. Reference-based face restoration models excel at recovering high-fidelity facial details using clean reference images. However, these methods typically focus solely on the face, neglecting the surrounding scene. Real-world degradations often affect entire image uniformly, not just isolated facial regions. This narrow focus limits the practical applicability of face-only restoration, leaving significant portions of an image degraded. While general-purpose restoration models exist, they often struggle with complex full-scene degradations. They frequently fail to preserve crucial elements like facial realism, identity consistency, and coherent human body structures. A major limitation is their non-degradation-aware nature, leading to undetermined predictions and visual artifacts. Face2Scene mitigates these limitations with a novel two-stage framework. It leverages reference-based face restoration to first estimate degradation and then guides the restoration of the entire image using this information. The face acts as a perceptual oracle, providing a robust prior. This strong degradation prior allows for consistent, high-fidelity restoration across the entire scene, encompassing body, clothing, and background, by explicitly guiding what corruption to undo. Now let's look inside stage 1 of Face2Scene. Faces as a degradation probe. We use the face as the anchor for estimating degradation, because faces have a stable geometry and they come with identity references. This makes them the most reliable region for extracting distortion cues. Given a degraded full scene image, we crop the face and feed it into a reference-based face restoration model. Using some reference images from the same identity, the model reconstructs a clean, high-quality face. You can see the workflow on the right. We crop the face, pass it through the reference-based face restoration model, and obtain a restored high-quality face, which later guide the full scene restoration. Stage 2 uses the restore face to guide the entire scene restoration. Fade degradation extraction. We take the high quality and low quality face pair and extract the face-derived degradation code. Fade is trained using contrastive learning. Multi-scale degradation tokens. This code is expanded into multi-scale tokens, so the model understands degradation at different information levels. Conditioning the diffusion model. These tokens condition a one-step diffusion model, guiding it to restore the whole scene consistently. Full scene reconstruction. The diffusion model then reconstructs the entire image with improved fidelity. The face-to-scene approach relies on diverse datasets, combining synthetic and real images to effectively train and validate its restoration capabilities. We synthesize full scene images for each identity in the CVPR dataset, and we also gather galleries from different people as real images. You can see those samples in this slide. Face2Scene consistently achieves the best overall performance on both synthetic validation dataset and synthetic real image validation dataset. Our method outperforms state-of-the-art baselines in distortion scores, perceptual and no-reference quality metrics, and FID. We also capture 100 real-world test images from 10 different identities using a Samsung S25 Edge smartphone. All images were recorded in RAW format with automatic exposure and ISO values set to 3200, 1600, and 800 to emulate diverse real-world degradations. To further introduce motion-related degradations, we additionally captured a subset of images with a motion blur. We then processed the raw files using the RAWPy library to obtain RGB images. These processed RGB images serve as the real degraded inputs for evaluating our model under realistic capture conditions. Again, Face2Scene outperformed other methods even in the real-world degradations. We also tried to answer a question: what do we learn from fading? Ideally, fading would encode degradations without including information about image content. To evaluate this, we apply 4 degradations on 10 random images and observe the cosine similarity between them on the output of the fading. This figure shows the left figure shows the average cosine similarity between different images using the same degradation, and the average cosine similarity across the same image using different degradations on the right one. This graph clearly shows fading concentrates dominantly on degradations while minimizing extraction of image content. We compare inference time across different diffusion-based restoration models. For Face2Scene, we show the separate time costs of the reference-based pre-processing and our final restoration as 2 different shades. While our method is not as efficient as standard 1SM models, which don't require an initial face restoration step, it is still consistently faster than current multi-SM models, despite performing on par or better than them in terms of image quality and restoration fidelity. Here we show qualitative comparisons on real-world images from the in-scene real dataset with synthetic degradation. You can see that Face2Scene restores both the face and the surrounding scene with much better clarity and coherence. Here is another example on synthetic images from the in-scene synthetic dataset with synthetic degradation. Here is also another example on real images from the in-scene real dataset with real-world degradations. As I said, images are taken using S25 Edge mobile phone in the real-world degradation settings. Overall, Face2Scene sets a new standard for image restoration by enabling accurate, coherent, and high-fidelity reconstruction of entire scenes. For example, facial oracle guidance. Faces enable precise degradation extraction, fading plus MapNet. Disentangle content from degradation, then map to multi-scale tokens. In-scene datasets. Curated synthetic plus real-world benchmarks for human-centric restoration. And we also achieve sought-out performance, best fidelity, and lowest artifact rate across all metrics. And finally, thank you so much for listening.